This is an example involving an elastic collision. We have object A with a mass of m moving to the right at v. Object B, also with a mass of m, is at rest. If object A collides with B elastically, what are the velocities of object A and B after the collision? The key to this problem is that we know momentum is conserved, but because it's an elastic collision, we also know that the kinetic energy of the system is conserved as well. Which means if I were to set this up, I know that the initial momentum of A before the collision plus the initial momentum of B before the collision is going to equal the momentum of A after the collision plus the momentum of B after the collision. That's a statement from conservation of momentum, which means that the mass of A times the initial velocity of A plus the mass of B times the initial velocity of B is going to equal the mass of A times the new velocity of A, which is why I use the little apostrophe, that means prime, plus the mass of B times the new velocity of B. We also know that energy is conserved, which means that we know that the kinetic energy of A plus the kinetic energy of B before the collision would equal the kinetic energy of A plus the kinetic energy of B after the collision. That means that if I were to set this up, 1 half ma VA squared plus 1 half mb VB squared equals 1 half the mass of A times the new velocity of A squared plus 1 half times the mass of B times the new velocity of B squared. That's our system that we have. What we know is that the mass of A is m and it's moving to the right at v. Since it's moving to the right, I'll define to the right as positive, which means it will have a positive b. So initially we have mv, and then for b, we know object b is initially at rest. So we have 0 for the velocity, which means we have no momentum for object b that we need to worry about initially. After the collision, I'm going to say that mass of A is just m times VA prime, plus we know mass of B is still m, and that equals VB prime, which means basically what I can do here is I can cancel out an m. So I'm left with V equals the velocity of A prime plus the velocity of B prime. If we look at the kinetic energies, I can basically cancel out all of my 1/2s. And if I cancel out all my 1/2s, because I have a 1/2 in everything, I'm left with m times v squared if I substitute in the fact that the mass of A is m and the initial velocity of A is v, plus 0 because I don't have any velocity initially for object B. That's going to equal the mass of A times the velocity of A prime squared plus the mass of B, which is just m, times the velocity of VB prime squared also. So if I cancel out the m's, I'm left with v squared equals VA squared plus VB prime squared. So what does that mean? Well, it means if you take a look at both of these, I end up having essentially one equation that's V equals VA plus VB squared, or VA prime plus VB prime. And I also have V squared equals VA prime squared plus VB prime squared. What I'm going to do then is I'm going to substitute VA prime plus VB prime in for my V squared. Now what this will get me is that VA prime plus VB prime squared equals VA prime squared plus VB prime squared. I know this looks like it's the same statement, but it's actually not, because if I distribute what I have on the left side, this ends up being VA prime squared plus 2 VA prime VB prime plus VB prime squared. And that equals VA prime squared plus VB prime squared. What I get then from this is that if I subtract VA prime squared from both sides, subtract VB prime squared from both sides, I get 2 times VA prime times VB prime equals 0. Well, that means that one of the velocities, either VA prime or VB prime, has to be 0 in order for this to occur. Now, so the question is, which one is going to be 0? Is it going to be VA prime or is it going to be VB prime? Well, since we know that the change in momentum of A, the magnitude of the change in momentum of A, has to equal the change in momentum of B. We know that A has an initial velocity of V, and then B has an initial velocity of 0. We know that we can't have object B continue to have a velocity of 0. Otherwise, the change in momentum of object B would be nothing. That means the change in momentum of object A would be nothing as well. And that just doesn't make sense. What that means is that after the collision, we know that the velocity of object A has to equal 0, which means that it must be object B that is moving. If I plug the 0 back into my original equation I have in red, I have V equals VA prime plus VB prime. That means VB prime must equal V. So what we know is that the velocity of A after the collision is going to be 0. The velocity of B after the collision is going to be V, which is the same speed that object A was moving at initially. Elastic collisions are a little tricky because you have your conservation of momentum and your conservation of kinetic energy. You are going to have to set up some of these systems, and sometimes they can be rather nasty. But what you have to do is you just kind of have to piece it together and just think through logically, does this make sense? Is this something that could happen?